Hi friends, today we are going into thermal unit constraints. We have studied different constraints in the case of unit commitment problem. So now we are going into what is meant by thermal unit constraint. So before going into the different types of constraints in thermal unit, we should understand that in thermal plants there are operating personnel who are taking care of the temperature, pressure of the steam before a unit can be switched on or switched off. So that should be kept in mind. Now we are going into the different constraints. Let us go into the first constraint. The first constraint is the minimum uptime constraint. So what is meant by minimum uptime constraint? If a unit is being switched, is in operation for some time, it cannot be directly switched off instantly. It requires some time for switching it off. And that time is known as the minimum uptime. So that is one of the constraints in the case of thermal unit. That is, some minimum uptime is needed before a unit is being switched off. So that is the first constraint. Now what is the second constraint? Second constraint is the minimum downtime constraint. Okay. So before a unit is being again connected back to a grid, that means that if it is already switched off, now before connecting it to the grid again, it requires some time. That time is known as the minimum downtime. Okay, so then that is the second constraint. So there should be some minimum downtime before it is being again connected back to the grid. So that is known as the minimum downtime constraint. Now we are going to the third constraint, that is the number of operating personnels. Okay, so there is a constraint on the number of operating personnels. We cannot appoint many operating personnels. It should be an optimum number. Okay. So that is mentioned as the constraint number of operating personnel in the thermal plants, especially if there are more than one unit in the plant, an optimum number of operating personnel is desirable. Okay, it should be enough to operate the units which are available in the plant. Okay, so the next one is next constraint is temperature and pressure. So a thermal unit is never connected to a grid before until the steam attains a particular temperature or pressure. Okay, the temperature and pressure should be maintained at a particular value before it is being connected to the grid. This is for the better efficiency of the plant. So this is one of the constraints. So after reaching the particular temperature or pressure, then only the thermal unit will be connected to the grid. So that is the next constraint. Okay, the next constraint is startup cost. Okay. So the fuel input to a unit from cold to the state when it is being connected to the grid. During that time, there is no other electric energy being produced. And this cost, that fuel input cost, is called the startup cost. That means when it is in the cold state, a completely switched off state, and it is in the completely cold state, and then we are going to switch it on and be connected to the grid. So that initial fuel input is called the startup cost. Okay, and the startup cost is not a fixed value. It depends upon what is the initial state of the unit. It depends upon what is the initial state of the unit. For example, if the unit is in the cold condition, initially if it is in the cold condition, then the startup cost is maximum. That means we have to give maximum fuel, then only it will be getting into the proper temperature and pressure before it is being connected to the grid. Okay. But if it is in the cold state, then initially in the cold state, then the cost required is very high. But if it was turned off recently, which means it is not cold and it is still relatively close to the operating temperature and pressure, then the startup cost is much lower. Then the startup cost will be lower. Okay. Now the first startup, which I just mentioned before, that is cold, from the cold condition, that cost is called the cold startup cost. And the second one, that means it was nearly in the operating temperature, that cost is known as that startup cost is known as the banking startup cost. Okay, so the first cost is called the cold startup cost, that will be higher. Okay, and the second one is the banking startup cost, which will be a lower one. Okay. Now, the two types of startup costs are given empirically as, you can see the equation here, where startup cost, cold start condition, Fc into 1 minus e raised to minus t by alpha into F plus Ff. where FC is the cold startup cost in MBTU, F is the full cost, FF is the fixed cost, that means what are the salaries of the operating personnel and maintenance expenses. Then alpha is the thermal time constant of the unit, T is the time in hours and unit T is the time in hours the unit was cooled. Then FT, that means FT is required in the startup cost during banking. Okay, so that will be explained now. Startup cost during the banking equation is equal to FT into T plus FT into T into F plus FF, where FT is the new term. FT is the cost of the maintaining unit at operating temperature and pressure. Okay, now you can just see a curve of the two types of startups. One is cold startup and the second one is the banking startup cost. Okay, number of hours is represented here. You can see the cold cost curve is shown on the upside, and the banking startup cost is shown as a straight line. The cold cost up is a curve and it is increasing, and further after 4 or 5 hours it is being reduced. But the banking cost, it is always in a ramp manner, that is, it is always in a increasing manner, linearly increasing manner. So that is what is meant by hydro constraint. So the next one is that is meant by thermal constraint. Now next one is the hydro constraint. So what is meant by hydro constraint? The problem of short-term hydro scheduling is mainly to determine the optimum hourly generation, the production of the hydro units, then the water flows through the generating stations, reservoir releases, and the storage levels. So these are the different constraints while we are solving or while we are making a hydro scheduling. Okay, so short-term hydro scheduling is to determine these all things, and the objective is to maximize the energy production from the available hydro resources. So the objective is to maximize the energy production from the hydro resources. Now, actually this hydro constraint is not working individually. Normally, we will be always explaining it with hydrothermal as hydrothermal coordination. Hydro constraint as well as thermal constraints are together working. So, in a hydrothermal system, short-term hydro scheduling is done as a part of hydrothermal coordination. That means a short-term hydro power plant should be scheduled in a short-term manner as a part of this hydrothermal coordination. Now, the objective of this one is to minimize the thermal production cost subject to meeting the load and other generating requirements. We have to minimize the thermal production cost, whereas we have to maximize the energy production also. Okay, so minimize the production cost, whereas to maximize the energy production from the hydro resources. So next one is what is meant by unit commitment problem solutions. So this unit commitment problem, as we already explained in the first class, it is a complex combinational mathematical optimization problem. So there are different methods as solution. There are different methods which are using the mathematical developments and the computing technologies. There are different methods available. Mainly we can classify into 3 techniques. One is the deterministic technique, second one is the meta-heuristic technique, and the third one is the hydrothermal coordination. So the first one is the deterministic technique, in which different methods like priority list, dynamic and linear programming methods are used, as well as decomposition technique is another one. There are several other methods also used in the deterministic technique. Okay, we are not going into further explanation of each of them. You just have to study which are the methods used. The next one, second one, is the meta-heuristic technique. In meta-heuristic technique comes the fuzzy logic method, artificial neural networks, and genetic algorithm. These all things are used for solving the UCP using the meta-heuristic techniques. Now, the third one of solution of UCP, that is unit commitment problem, is hydrothermal coordination, which I just pointed out in the previous hydro constraints. So, hydrothermal coordination means it requires a solution for the thermal unit commitments, as well as we have to make a schedule for the hydro power plants, hydro units also. Okay, now mainly the method used is decomposition method, which involves the unit commitment and hydro scheduling sub-problems. So these are the different methods which are used for solving the unit commitment problem. Hope you understood. Thank you very much for listening.